Hello everyone, I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. And this June 2025 lecture series, we are going to discuss about Zener Diode in electric circuits and electron devices. Shall we start? See, what do you mean by Zener Diode? What is a Zener Diode? A Zener Diode or Zener Diode is also known as a breakdown diode, which is heavily doped semiconductor device that is uh, prominently designed to operate in a reverse direction. When the voltage across the terminals of a Zener diode is reversed and the potential reaches Zener voltage, which is also called as a knee voltage, the junction breaks down and the current flows in the reverse direction. This effect is called as Zener effect. See Zener diode. Here we have symbol of Zener diode, and in structure of Zener diode we have anode, cathode, and we have P type substrate and N diffusion, and in the top we have layer of SiO2 and metallic layer. See here, see the symbol difference. Zener diode is prominently it is designed for reverse biasing, and again it is working of Zener diode. And Zener diode, it allows electric current in forward direction like a normal diode, but it also allows electric current in the reverse direction if the applied reverse voltage is greater than the Zener voltage. See, it is always connected in reverse direction because it is specifically designed to work in reverse direction. For reverse direction operation, it is highly doped and the depletion width is very thin. Due to this, more current flows through the Zener diode as compared to the normal PN junction diode. Here, this Zener diode, it shows two breakdown approach, Zener breakdown and avalanche breakdown. It is normally act like PN junction diode, but it is suits for reverse bias applications. Zener diode is perfectly suits for reverse direction applications. See, we know that it has two breakdowns. While talking about PN junction, it has only one breakdown voltage. Here we have two. One is Zener breakdown, another one is avalanche breakdown. See the diagram. We have P type, N type, battery, negative ion and positive ion. Here free electrons, it hits the atom at high speed, and we have N type. When high reverse voltage is applied to the PN junction diode, free electrons, that is our minority carriers, it gains large amount of energy and accelerated to greater velocities. These electrons are again accelerated and collide with other atoms. As a result, the electric current in the diode increases rapidly. Avalanche breakdown occurs in Zener diodes with Zener voltage Vz greater than 6 volt. See the diagram. We have P type, N type, and we have negative ions and positive ions. Free electrons hits the atom at a high speed. That time, see in this free electrons hits the atom in high speed. Here, the negative ion is started moving to another side. Here, the avalanche breakdown occurs in Zener diodes with the Zener voltage Vz greater than 6 volt. Remember that. And what do you mean by this Zener breakdown? Zener breakdown occurs in heavily doped PN junction diodes because of their narrow depletion region. When reverse biased voltage applied to the diode is increased, the narrow depletion region generates strong electric field. When a reverse biased voltage applied to the diode reaches closer to Zener voltage, the electric field in the depletion region is strong enough to pull electrons from their valence band. At Zener breakdown region, a small increase in voltage will rapidly increase the electric current. See the diagram. Here we have P type, N type. Here strong electric field pulls valence electrons from the ions. It has narrow depletion region. See, here we have both positive and negative ions in depletion region. Here the strong electric field, it pulls the valence electrons from the ions. See the VI characteristics of Zener diode. we have forward current and reverse current, forward voltage and reverse voltage. Here we are in this graph we have mentioned germanium as well as silicon. In forward biasing, while the voltage increases, current also increases. But in reverse bias condition, it has breakdowns, Zener breakdown as well as avalanche breakdown. And Zener diode, which is mainly act as voltage regulator, which is used for regulating the voltage of a circuit. It is having the ability to keep the output voltage fixed regardless of variation in input voltage or load current. It doesn't matter. It regulates the voltages of a circuits and it keeps the output fixed. Until load voltage is less than the breakdown voltage, Zener diode does not show conduction. As the voltage at the load increases, then breakdown voltage, the device now starts conduction in the breakdown region. Thus, at the breakdown region, a constant voltage is maintained. See, in this June 2025 lecture series, we have discussed about PN junction diode, Zener diode, and BJT. These are all the main electronic components used in real-time applications, and it has both forward and reverse biasing. Based on the application, we will choose either forward or reverse bias. But while comparing BJT, avalanche and Zener, Zener is mainly for reverse bias applications, and BJT and PN junction is preferred over Zener for forward bias applications. Thank you for watching.